So this is lesson 25. Our I can statements are, I can investigate a problem that can be solved by reasoning, and I can investigate a problem that can be solved by creating equations in one variable. I can also compare the algebraic approach, which is kind of breaking it down the way we've been doing it, and the numerical approach, which is kind of those tape diagrams and stuff. So, I want you to start by doing exercise 1 on your own. I'm going to show you the answers to it afterwards. It's important that you know how to do it to be able to do the rest of these exercises. But if you're going to watch the video and not pay and just copy down the answers and not pay attention to how to do it, you're going to be the one who loses out when you do that assessment. You guys have an assessment coming up. I think it'll be probably about next week. We'll probably review next Monday and you guys will be ready to assess on like Tuesday. So, you guys really need to pull it together and make sure you're paying attention and doing the work on your own and checking it with my answers. So go ahead and pause the video and set a timer for about 7 minutes. Go ahead and do this. If you finish before that timer's up, obviously don't hesitate to go back and just start the video back up. Okay, it says, solve the following problem, first using a tape diagram, and then using an equation. So we're going to go through and underline the important information. In a school choir, 1/2 of the members were girls. At the end of the year, 3 boys left, and the ratio of boys to girls became 3 to 4. How many boys remained is what it's asking. So, start by using a tape diagram. We're going to have, this is the tape diagram for originally. This is boys. I'm going to label it B and G. This is girls. We know that the difference between the boys and the girls at the end of the year is 3 because that's how many left. Okay, we got rid of those. And then at the end of the year, we then have, redraw that one section goes away because those 3 boys, they went away, they left. Okay? So we know we can look at this as 1 unit is 3 boys because we got rid of 1 and we now have a ratio of 3 to 4. So if we know each box is 3, we can fill those in and then we can say we have 3 units left for the boys, so we can do 3 times 3 is equal to 9, so there are 9 boys left. Okay, that's doing it with a model and a tape diagram. If we set an equation, we can say, we know that half were girls and half were boys, so we know that boys and girls are equal. So B is equal to the number of boys originally, I'm just going to put orig, and B is also equal to the number of girls that was original because they were split in half. And that's kind of, if you backtrack to this tape diagram, that's kind of how we knew that these were the same size to start with. I know they don't really look like they're the same size, but I can fix that and draw them so they look like they're a little closer in size. Okay? So, then, at the end of the year, the boys was equal to the total boys, take away 3, because we lost 3 kids. So then we know our ratio of boys to girls, I'm going to use big letters, capital letters, to signify the difference. Boys to girls was, at the end of the year, the boys take away 3 to the same amount of girls. And we know that this is also equal to 3 to 4. So then we can kind of readjust that algebra. We can look at this as b minus 3 is equal to 3. And we know, well, we really actually don't want to do that. We're going to backtrack a little bit. We could do that, but we don't know that our ratio is always going to be 3 and 4. It could be 6 and 8. They could be equivalent ratios. So if we backtrack and we do values instead, we can do b minus 3 over b, because that would be the value of that ratio, is equal to the value of this ratio, our 3 to 4. And then we solve it like we would before. To get rid of that b on the bottom, we multiply by b. Okay, and then I don't like subtracting fractions or a whole number from a fraction because it kind of makes things a little messy. So I'm going to go this way. You could have gone the other way. It's okay to take 1b away from that. So then you have 1/4 b minus 3 is equal to 0. I want to move that 3, so I add it. So then I have 1/4 b is equal to 3. Want to make that b so it's a 1, so we multiply by its reciprocal. Those cancel each other out. We do the same thing over here. It's a little cramped, I know, but we're working with what we got. So b is equal to 12. So that's the number of total. So we want to know how many are left. I'm going to kind of draw a little arrow to get us over here. So then we know that at the end of the year they lost 3, and 12 minus 3 is 9. We should have gotten the same answer for both of these. It makes sense that we did. Okay, we're going to move on to part B. Which problem solution, the one using the tape diagram, so this stuff, or the one using the equations, was easier to set up and solve, and why? You guys could have many different answers. It might be easier for you to use the picture because it makes more sense to see it visually. Might be easier for you to use the algebra because it's just easier for you to manipulate. For me, I prefer the algebra because it's easier for me to manipulate it. And for me, that was the way I learned it. When I learned it, I didn't have tape diagrams. Tape diagrams are really great. But for me, I didn't have that, so this is what I'm used to. And maybe that's the case with you guys. Maybe you guys touched on this stuff in Springboard when you did it last year, and it doesn't quite fit, so you guys are used to the algebra part of it. Okay? As long as you have an answer. Okay, we're going to move on to the next part. The mathematical modeling exercise / exercise 2. You guys have 27, you guys have a lot of time to work on this problem. So, if you guys don't get through it by the last 10 minutes of class, that's when you need to stop. So right now I want you to look at the clock, see how long is left of class. Take 10 minutes away from that. That's how long you're going to set your timer for, okay? Once I'm done reading, that's what you're going to do. Okay, read the following problem. All the printing presses at a print shop were scheduled to make copies of a novel and a cookbook. They were to print the same number of copies of each book, underline same number of copies. But the novel had twice as many pages. Novel, twice as many pages. All of the printing presses worked for the first day on the larger book, turning out novels, and finished printing all the copies by evening of the second day. The second group worked on the cookbook but did not finish by evening. One printing press, working for 2 additional full days, finished the cookbooks. If all the printing presses printed pages at the same rate, how many printing presses are there at the print shop? So underline how many printing presses. okay? You need to spend the next 20 minutes or so, it might be a little bit less than that, trying to figure that out. This is something that would be really great for you guys to kind of work on together. So if you guys get to this point, it might be a good idea for you guys all to move to one table and work on that whispering that I know we can do and work on it together because it's really good to bounce ideas off of each other. Okay? Remember what we know. You need to think about everything that we underline. One thing to keep in mind, on that first day, all of those printing presses are being used. On that second day, only about half of them are being used. Okay? And then on that third and fourth day, you only are using one printing press to print the rest of those cookbooks. And remember, you're trying to find the number of printing presses at the print shop. Okay, so I want you to go through and do A. A says solve it using a tape diagram. So make sure you use that tape diagram. B says solve it by setting up an equation. B, you have to do the algebra. You need to be able to do both of those parts. Okay, so pause it and take however long you have left in class minus those 10 minutes for your exit ticket, and that's what I want you to do. Okay, go ahead. Make sure you pause the video because I'm only going to take about 20 seconds and then I'm going to keep going with talking about our exit ticket. Okay, we're going to move on to our exit ticket. We're going to go through it. Underline the important parts. If you don't need this, fine. But I want to make sure you have all the information you can to do what you need. Suppose we know that the print shop had 8 printing presses. This connects back to that problem you just did. And each printing press runs at a constant speed of 5,000 pages per hour for 6 hours a day. Okay? Compute the total number of pages printed for the cookbook job. Then the total number of pages printed for the novel job. Okay? That goes back to that situation in exercise 2 that we just did. If you guys get ready for your exit ticket and you want to check your answers, please come see me before you're ready to start it. I have the answers right here in my book. Okay, next. Describe a scenario. So underline describe a scenario where it would make sense for the job schedule to schedule both jobs as described in exercise 2. So you're coming up with a scenario where it would make sense to schedule both those jobs. 3 is a bonus. So if you do 3, you can pull this up to a 4 on this exit ticket. And I will give you credit for that standard. If you just do 1 and 2 and you get them completely correct, that's a 2. If you can do 3 and get it all the way correct, that can pull you up to a 4. And like I said, I will put that in your grade book and that will be counted. Okay? The novel was 500 pages. Cookbook was 250 pages. How many copies were printed? Okay, we've gone through, we've underlined all the important information. Go ahead and do that exit ticket. Remember, when you're done your exit ticket, put the whole packet in my inbox. Not just that one exit ticket. Don't rip it off. Make sure your name is on all of these exit tickets so I know who they belong to. I have already had people turn in their exit ticket packets without their names on them. Before you pause and move on, here is your problem set. If you finish your exit ticket, I want you to work on these. Your must-dos are 1, 2, 3, and 7. Your could-dos are 5. And your challenge questions are 4 and 6. Remember, these are right in your book. And there's your exit ticket if you need it. I'm going to leave it up for about 10 seconds before I end the video.